Hi, I'm Pat Kelly. Okay, in this problem, they ask us to represent this plane curve with a vector valued function. In other words, they give us this equation that has the x's and y's in it, and our job is to come up with that r of t function, vector function. Right, so the way that I'm going to do this is we have to use this equation to motivate what our components will be for the vector that we'll end up with. Okay? So you have to look at this equation a little bit and see what kind of inspiration you get, I guess. And to me, this equation has Pythagorean undertones. Don't Google that, I just made it up. What I mean, something squared plus something squared equals something squared, okay? That's gonna direct me with the manipulation that I'm gonna do right now. So my manipulation is just gonna be to divide over the 25, x squared over 25 plus y squared 25 equals 1, and even rewrite that just a little bit as x over 5 parentheses squared plus y over 5 parentheses squared equals 1. And so that Pythagorean theme that I have here now looks like the Pythagorean identity from trig. Pythagorean identity from trig. Cosine squared plus sine squared equals 1. So that's going to motivate me over here then to let what's inside that first set of parentheses, x over 5, equal cosine of t. And also, I am going to let what's inside the second set of parentheses, y over 5, I'm going to make that equal to sine of t. So if you can see that Pythagorean identity kicking in here, x over 5 squared, that's cosine squared. Y over 5 squared, that's my sine squared. We know that that equals 1, okay? Furthermore, what that allows me to do is in each of these two equations solve for our typical rectangular variable, x and y. X equals, and you're getting things in terms of the t variable then, y equals 5 sine of t. And now you've got good, firm expressions for the first component and the second component. In other words, a final answer here is r of t equals, and for my first component, I'm grabbing the x, which is 5 cosine of t, comma, and for my second component, I'm grabbing the y, which is 5 sine of t. Okay, that's my answer. That's what they wanted. And we didn't use the graph at all, but just to kind of even convince yourself what's going on here, if you start playing around with different values of t, you'll produce that same circle centered at 0, 0 with a radius of 5. The same circle that we would get from the x squared plus y squared equals 25. That's the point. These two will end up giving you the same graph. Okay? Thanks, and hope that helps.